So we're getting ready to take the final, and I've got a review here, and this is an unusual one. We are basically giving you questions that are very much like the final ahead of time, and we're going to also give you some tips here on day one of how to start, and then tomorrow we'll grade this thing. Then we'll have a couple days where I will go over different topics more in depth. And then when I'm gone on that Tuesday of next week, we'll take a second one of these as a practice test. And the answer key for that will get posted too. And then you will know exactly, what you need to study for the final. All right. So here we go on the first one. I'm going to allow you, if you don't want to do the second part. I mean, the key will have the second part there. So if you do the first part and you get it wrong, maybe you should do the second part. But I'm going to say you can skip that first part. Anytime I'm doing sets, I think it's easiest to make a number line for it. So right now, I know this goes between 1 and 2. And it doesn't include them because it would have brackets if they were included. And then on the 3, it's a bracket, so then that means it's filled in, and it goes forever towards infinity. That's number line notation. Now, they didn't want that. They wanted set builder, but I'm telling you, set builder's hard. Number lines are easy. I'd start with a number line. Then to write set builder, you're going to want x colon, and then you'll need an end parenthesis, and you want things like a union or an intersect, and I even told the kids, on this first one, you want a union. Oh, big surprise. This says you right in the problem, right? And then I'd write this part and put it here. And I'd write this part and put it there. And that's how I would do my set builder notation. Okay, so there's my tip for number 1. That's a pretty extensive tip. Not all of these tips are going to be that extensive. All right, I'm going to remind you on, and this is the part where you guys in class, since I had told you this other stuff before, now I'd pay attention, and I would write little tips for yourself next to each of these questions. Okay? This one means and it usually gives you a smaller answer. It's also an intersection. This means or. It's also called a union, and it gives you a bigger answer. So if I said, like, this one, if it was just A and B, intersect would mean this part. If it was just A and B, oops, got to make them overlap at least. And if it's union, that would mean all of this. The last one that you might want to know is if it does that, that means not. So not B. It's called the complement of B. Okay, so you want an answer for this that's kind of like A union not B intersected with C or something like that. Maybe parentheses around that. I'm not saying that's the right answer, but to get this answer, it's pretty complicated. I'm thinking you probably aren't going to be able to get it done with just 2 things. It'll probably be like a nested thing like this. Not saying that's the answer, of course, but something like that. Okay, on to number 3. If you really needed to, you could do a reflection across that line because that's what inverse means. That means inverse. Okay, but it didn't say you had to reflect the graph. So who's got a better idea? Yes?
Find the domain and range of regular f of x.
Very good. Find the domain and range of regular f of x, and then what?
And then flip it.
And then flip it. All right. If you've forgotten domain and range, you may have to talk to me privately later on that one. Okay. This one, find f of -4. We're going to put -4 into the f function, and then just solve it. Don't overthink this. If your answer comes out that you can simplify it, like, square root of 12, you should simplify it. Root 4, root 3. I'm not saying this is your answer, but it'll be kind of like that. You can't leave answers unsimplified. You'd want to say 2 root 3 or something like that. Okay. This one, you're going to take the whole function as it is, just f of x, which is right here, and you're going to square it. I hope you know what happens when you have a square root and you square it. If nothing else, it means times itself. On this, I would do the g of 3 first, and then times it by 2. Everybody can do g of 3. Just stick a 3 in this. Then you times it by 2. Okay, next one for tips on number 5. Your answer on this just looks like this. Y equals x squared, and then it says right 3. I'm totally doing this wrong. Vertical reflection, let's say I think that means put a negative 1 down here. Okay, the answer looks something like this, but that's not the right answer. Don't overthink this, except for the order part. Notice it needs you to do the shift right first, so you better do something that'll force the right to happen first. So the order you do it in is important. Parentheses affect order. Okay, on to number 6. 5 seconds. Who knows the formula for the coordinates of the vertex? Does anybody remember that formula? All right, 2 kids were solid on that. Sasha, what do you say? Negative b over 2a. That gets you your x of your vertex. And then you do f of that. That's how you find the vertex of a quadratic. And if you just wanted the axis of symmetry, that would have been the x equals line. But, all right, on to number 7. Limit notation. Here's an example of a limit. Limit of the function as x approaches, and I'm going to show you an example of one. Let's say my graph goes like this. Then it would be x approaches infinity equals infinity. This is where the x number goes, obviously. That's the y value when you get there. Okay, so that's what limits kind of look like. Next, number 8. This one's where you have a rate for one person plus the rate for the other person, and it equals the total rate. And my other tip is use units. At the first, you want to use like he can do 6 per minute, and you got to put the units in there. Otherwise, you might do things upside down. So there's my tip on number 8. Okay, moving on. The other reason for units on that last one is because what if one's in hours and one's in minutes? You got to get them all to be in minutes. You got to be all the same unit. Otherwise, they'll mess you up. Okay, on this one, rewrite is my tip. On the other, I would say simplify is what you're doing, but I think it'll involve condensing. And remember, if you can condense it, you should. But do you remember this kind of a thing where that, if those had been the same base, then it would have simplified? Well, yeah, the number 11 is actually too tough for an R2. I'm not saying you shouldn't do it. There's something like this on the test. But it might not be that hard. That's a brutal one. But struggle through it, see if you can do it. Ask a kid next to you if necessary. Okay, number 12. On this one, I'm just going to remind you that in here we have, this is where you put the point. And that's where you put the slope. It's the M. And that's why they call it point slope. The point goes here. Slope goes where M is. Okay. There are 4 lines there. It'll give you good practice. If you're stuck on these, ask me. All right, number 13. Domain. The domain is what you can safely feed the function. A common mess up is people think, well, you can't feed it a -5 because the top will turn into 0. We don't care. Top can turn into 0. It's the bottom. Okay? So basically, almost everything works except probably a couple things. Since it doesn't say, I'd use a number line for my answer. It can be everything except this and this. All right, moving on to number 14. On number 14, you stick x plus h in here, you stick x plus h into the function, then you subtract this function. It's really common to forget the parentheses around that function. So first you stick in x plus h, then don't forget that this, you gotta put a negative, this negative here. I'm just reminding you, you gotta distribute that throughout the function. 15-minute warning. And if h doesn't cancel, see how there's an h on the bottom? Then you did something wrong. If h doesn't cancel, there's an h in everything on the top, and then there's an h on the bottom. If that h doesn't cancel, you did something wrong. Okay, number 15. Switch x and y. This is the universal sign for switch them. And then solve. Oh, you're going to need one of these. You can do it from digital, but I do have a paper, so why don't you come up and get it? You seem to be in a good mood. Is there a reason?
Yeah, I passed.
All right, congratulations.
Thanks.
We have another driver on the road, ladies and gentlemen. All right, on to number 16. The entire graph is given at the right. Find the domain. Domain basically means how far can it go this way and this way. Are there some things it can't be? You have to be the judge of that. But when you look at this and you look at this, they're right above each other, and only one of them is got a function that, you know, like it's working at only one of them. So this passes the vertical line test. So it appears that it is a function. And every time it doesn't work like here, it does work above it. So that means to me that the domain seems to be pretty solid. So I hope you know what that means. Okay, the y-intercept, that's just where it hits the y-axis. That's pretty easy. F of x equals 1. That's like a line at 1. You just have to figure out if it's a line like this at 1 or a line like this at 1. Hopefully you know what the difference is. Okay. I think maximums and intervals are pretty easy. Intervals look like this, something comma something. All right, on number 17. My first thing is subtract 20 from both sides. Why? Because it's a quadratic, and you always want to set them what? Yes? Equal to 0. So 2x squared plus 3x minus 20, well, I guess in this case, less than 0. And whenever I see one of those, that reminds me to make a number line, because my answer is going to be a range of values. So you'll test intervals. So like your answer might be like that and that, or it might be the other way around, but I'd leave my answer on a number line. And of course, if you can factor it, you should. Okay. And on to the last page. Stay with me. Take notes. Telling you, this will help when you're doing this at home tonight. On number 18, sketch a possible graph of the following polynomial. Well, this is a snake. You guys remember what makes it a snake? The multiplicity of what? Multiplicity of 3. That one has a multiplicity of 2, so that's a bounce. And who remembers what that negative in front does? Nobody remembers? Oh, Oliver remembers. Sorry, Oscar remembers.
Makes it go down on the right.
Down on right. So your final answer is going to look something like this, except that's not it, but, you know, something like that. Also, wouldn't it be handy if you knew the y-intercept? Finish this sentence for me. Y-intercepts are where, what? Where x equals 0. So you stick in x equals 0 and you could solve for your y-intercept. Doesn't take long, take notes. It took me 15 seconds at most to write that. Y-intercepts when x equals 0. Okay, number 19. For this polynomial, x equals 0, x equals 7 are x-intercepts. Do you think I can actually do polynomial long division with a 0 out here? Is that what I'm supposed to do? Is that how that works? No. So what do you put out there? X plus 0 or x minus 0. Do you get that either one of those is really just what? It's really just x. And so then x can be factored out of this thing. That's what I'd do first, is I'd factor out the x. I'd just do that in my head. Can you guys just do that in your head? You don't need long division for that, right? So then, what would you put on the outside here? After you factor out the x, you'll have this new thing. What goes on the outside, though? I'll give you a hint. It has to do with the 7. That's your job to finish the rest. I'm just giving you hints, not answering all the questions. And the last thing is number 20. All right, this one has two different kinds of asymptotes. Vertical asymptotes, they come from the denominator. What on the denominator would give us an asymptote? Well, nothing yet, but as soon as you got it factored, then there'd be some things that would give you vertical asymptotes. And they're x equals things. Next notes to take. What if you had to do the horizontal asymptotes? You got 3 rules I want to review with you. Bob, bigger on bottom, y equals 0, plus whatever's on the outside. Is there anything on the outside? No. If it's a sob, it's the same on both, then it's y equals a ratio of the lead coefficients, like -1 and 2. Or if it's a bob sob, what's the last kind? You guys are my quietest class. Come on. Bigger on bottom, same on both, or Oscar?
It's bigger on the top here.
Yup. And then it's none. There's no buts. There aren't any now, but there will be when you're my age. You're probably walking down the street, delivering some person's groceries. Okay. And intercepts. The x-intercept is where y equals 0. How about the y-intercept? If you wanted to find the y-intercept, you'd put in what? X equals 0. Y-intercept is x equals 0. X-intercept or y equals 0. All right. And then holes. If you end up with something like this, that creates a hole. Where? At -3 for x, comma, then you have to stick the -3 in the other part of the function that didn't cancel. That's how holes work. Okay. Do you think I just taught you everything from first semester? No. But did I give you a tip on every question? Yes. Are you supposed to be an expert yet? No. The final would be tomorrow if you're supposed to be an expert right now. Okay. So I hope this helps. And then your job tonight is to finish this like it's a test. Then we're going to grade it tomorrow. And we'll see how you do on your first try. If you rock it on your first try, you know you don't have to spend too much more time studying. If you get like a C on your first try, well then, got some time to fix it. All right, so get it done tonight. That's all I have for you for today.